Hello, lovely people. The moment you've all been waiting for, how to do impulse response with a USB microphone. So if you're following my channel, probably you know that I do my impulse response using a Focusrite Scarlett audio interface, XLR microphone, and a physical cable loop back. Now, I did mention in one of my tuning videos that you cannot do impulse response, time alignment, and phase alignment using a regular USB microphone such as UMIC 1. And I was wrong. I was corrected by a person named Peter Hermans, and this video is gonna be all credit is gonna go to him, because what I'm gonna be doing, I'm gonna be following his guide that he made specifically for measuring phase and doing time alignment using a USB microphone. If you want to find the paper version, the PDF guide, and follow it by yourself, you need to go to RTA in Cars, and on the top of the group there's a pinned post with his PDF file, and there you can download it and you can do exactly the same what I'm gonna do in this video. So just a heads up, it's gonna be a very long video because it's an extremely, in my opinion, tedious process, because it needs a lot of workarounds to make it work, but it is possible to time align and phase align your system using a simple USB microphone. So I'm gonna tell you a little bit about my setup. What I have here is, I have my laptop. I'm gonna be using everything here. I have my amps and DSP in the back. I have my UMIC just here in the middle of the seat. For this specific purpose, what I'm doing here, it absolutely doesn't matter where and how the microphone is, because this is going to be just to go through the motions and through REW software, not to achieve the best possible results. So you will see when we're going to take the frequency response, it's not going to be ideal, but it's totally fine. So what you want to do when you're going to be doing this, you will want to have some kind of a stand and have the microphone, the tip of the microphone, right in the middle of your head where you usually sit in your listening position. Now, we do need to feed a signal from REW, from our laptop, into the back, into the DSP. I have a Helix DSP, and I will be using a USB cable that goes into it's not a DAC, but it's a digital to digital converter. So this is SMSL PO100 Pro. It costs like £50 or something, and what it does, it gives me USB out of the laptop or out of the phone and coax into the DSP in the very back. Now for this, you see that we do not have a loop back, so we will need to use something else. Now what? We're gonna jump into the laptop and I'm gonna show you everything. So pay attention and rewind the video, skip back as many times as you want, download the guide, print it and use it, because there's a lot of steps. So here we go. So let's not waste any more time and let's go straight to the workarounds. This is my system. I reset the time alignment to 0, all the phase, everything to 0, just to start fresh. Now, the first thing that we need to do is we need to go to input output, and we will need to rearrange the inputs and outputs. So I'm using a Helix DSP that has virtual routing. I will be using the digital signal, which is this one. So digital left, right goes into there. And then we have the virtuals going into the actual speakers. Now, why do we need to do this? The whole thing about measuring phase with REW is that you can have, well, to be honest, with any other software as well, the timing, you can have loop back if you have like Focusrite Scarlett interface or whatever 2-channel audio interface with the loop back cable. And you can use acoustical timing reference. So this acoustical timing reference is a small chirp that is in the beginning and at the end of the actual sweep. That chirp is about 4000 hertz, and it's played by the tweeter. So the whole thing is that we need to rearrange our system in a way that we could have a tweeter playing the chirp, and the whole system, whatever we want, everything else. So I know it's going to be very difficult to follow, but since I live in the UK and I have a right-hand driven car, I need my left tweeter to be the one that is playing the chirp. So with the routing, what I have, digital, I didn't change anything. I left everything as it is. So left, right, left, right, left, right. But with the virtual is, I'm playing left signal only to the left tweeter, and a right signal to all of the other drivers. So you see right, right, right goes to right mid, left mid bass, right mid bass, and both subwoofers. So I have same signal going to all of the speakers apart from one, which is the left tweeter. Now in REW, when we set up, let's go to the settings. When we set up everything, so this one is my output device, which is the SMSL Pro. That's my output. And this is my input. So input is my UMIC. The output, all the tones that I'm going to be playing, the sine sweep set or whatever, I need it to go out of the right output. So right side, because the right one is going to go into all of the drivers. Now the timing reference output is the one that does the actual chirp, and this I need it to be played only by the tweeter. That's why it's left, and as you can see here, it's playing left. So when I'm going to be playing any kind of tone, I will have chirp coming from the left tweeter. Then I'm going to have the actual sweep coming from any of the drivers that I'm going to choose, and the chirp again coming from the tweeter. So since the tweeter is in the same location physically, it doesn't move anywhere, I have the same reference for all of the drivers. Now another thing that I had to change is, if you go to preferences and analysis here, you need to make sure that this adjust clock with acoustical reference is enabled. And another thing that I changed is default width of the gating. I chose it 40 milliseconds. So 40 milliseconds lets me go down to 20 hertz. Because if you're going to choose lower, you're not going to be able to measure the subwoofer correctly. And another thing, I'm just using some smoothing. So because it's a lot of reflections in the car, especially for the tweeters and the mid-ranges, it doesn't really matter, but it's just, it looks nicer. So I'm choosing 1/3 smoothing for all my sweeps. So let's make a example sweep just for example. So what I'm going to be doing is, I am enabling two of these drivers. I'm enabling left tweeter, and I'm enabling right tweeter. So what's going to happen is the chirp is going to come from the left tweeter, then the sweep from the right tweeter, and the chirp again from the left, because everything here is set up like this. I'm using acoustical timing reference. So the length, you can choose whatever you want. I'm choosing short one, 5 seconds, because that's plenty enough. 20 to 20, so you wouldn't have to change anything. Sweep goes all the way, so same for subwoofers, all the way up to the tweeters. Level, I keep it at -3. You can have whatever you want. It doesn't really matter as long as you have enough volume. Now, all the other settings are kind of default. So I'm playing the reference, which is the chirp again, is going to be a lot of repetition because it has to be like that. Reference chirp from the left side, and the main thing from the right side. So now I'm going to do a sweep. So you can see it was a chirp, sweep, and a chirp. And this is the frequency response. The frequency response absolutely doesn't matter, because the microphone is stationary and there's going to be lots of peaks and dips, so don't look at it. What is important for us is the actual impulse, which is this. And if we go to SPL and phase, we have the phase information. But again, for tweeters, it doesn't matter. What's important is the impulse, which is here. If we're going to zoom in a little bit, we're going to have the actual impulse response that starts with a chirp. Now, the problem is when you're using a USB microphone, the USB microphone inside has an audio cart, like a device, and your laptop has another one, and the DSP has another one, and the DAC, if you use it, has another one. And what happens without the loop back is that the timing is not following basically each other, and you can have some lagging or whatever, and you have what is called a clock drift. So every measurement that you make is going to be slightly different. That's why it's important when we're going to compare two drivers to make two measurements right one after each other to minimize the clock drift. The 0 point is, for example, here for us, but it absolutely doesn't matter again, because what we're interested in is relative time differences between left and right driver. Now here comes the tricky part. When we want to measure, so in this case, we did measure the right tweeter, which is the output B. If we want to measure the left tweeter, because it is a reference as well, so it's the same, it's the measurement and the reference. So it's a bit tricky. So for this one, we need to change this one to left plus right. And we're going to have, from this left tweeter, playing both the reference signal and the actual sweep. So I'm going to select only one tweeter, and I'm going to take a measurement. There we go. Now, if we want to compare, so this was my left, and this is the right. If we want to compare these two, we need to go to overlays, and we can see here we have the left one and we have the right one, and we can see that they are arriving at different times. Now what we need to do is we need to apply some delay to this tweeter, which is the right one, which in my case is going to be the closest one to me. So how much delay do I need to apply? First of all, what I'm going to do is I'm going to click my cursor here, then I'm going to go here, and I'm going to choose set time 0 at cursor, like that. So it shifted the graph, and now I have the T0 exactly where this starts. Now I know that this is 0. If I'm going to choose a second point here for the second, for the right side, it shows me 1.12 milliseconds. So what I'm going to do, I'm going to go to my DSP, and to the right side, I'm going to apply 1.12 milliseconds of delay. And then I'm going to measure it again. So I'm enabling both because I need this chirp and I need this measurement. I'm going to REW, measure, and now again, this is the tricky part, and I highly suggest reading Peter's document because it is a bit confusing. But again, chirp from the left side, measurement from the right. Let's measure. We have the measurement, so this is going to be my right side plus delay. Let's compare it in overlays. There we go. So I have my left and I have my right plus delay. And you can see that they're very close. Not ideal, but very close. Now the question is why? It could be because of the clock drift, or it could be because I didn't set the timing exactly right. So according to Peter's document, what he suggests to do, he suggests to measure two drivers very fast, one after another. As well, he does suggest to add right here, to add estimate IR delay into the measurement, which adds like a reference, basically zeroes out the time. You can add it here, timing offset. but I don't feel the need for it just because, again, the time is relative. So it doesn't really matter where the 0 is, because in overlays, you can put the 0 wherever you want. So let me very quickly measure both of these tweeters again, just for you to show, and you're going to see how to do it very fast. So first of all, we're going to take the left one. Again, we're going to go to measure. Here we're going to choose left plus right. I'm going to measure. I'm going to name this left. Then I'm going to choose both tweeters. Back to REW, measure. Now only right. And this is going to be the right one. So now I have two measurements that are measured one after each other. And you can see now they're matching. Not perfect, but they're matching very, very good. For tweeters, is perfectly fine. So now we know that our tweeters are aligned. And this is the thing. The more time it takes between two measurements, the more this clock drift appears. Okay, so we have both tweeters, and we know that these tweeters are aligned to each other. Left and right, perfect. Now we're going to do exactly the same for the mid-ranges. So I'm going to delete the tweeters because there's a lot of measurements. You can keep them if you name them properly, but I'm going to delete them because I don't really need them. So I'm going to mute this, and I'm going to enable the left mid-range. So this one. And I'm going to measure left mid-range, and then straight away I'm going to measure the right mid-range. So let's do that. Left mid-range. Cool. Straight away, swap to the right mid-range without changing anything in REW. We're going to keep the same. Cool. So the only time you have to change this output is when you want to measure the tweeter. Because if you remember, when we did the input outputs in the DSP, all the drivers are coming from the right side, and only the tweeter is coming from the left tweeter. So only when you want to measure the left tweeter, you have to change it. But other than that, all the other drivers are on this. So let's have a look at our mid-ranges. I'm going to close this. So that was left, and this was right. I always start measuring from the further one, because the closer one will need to add delay. And here you can see we have the right one, which is the closest to the microphone, needs delay adding. So what I'm going to do is I'm going to choose this point here, and I'm going to set T at 0. It's just for the graph, just to better read it. And as you can see, this where the rising point is, what we need to do, we need to align not the peak, but the rising point, exactly the same as we do with home impulse. So the rising point on one driver is 0. The other driver, which is here, is 0.95 milliseconds. So let's add, so this is the right one, yeah? Let's add the right mid-range, 0.95. Okay, and again, what I'm going to do is I'm going to remeasure both drivers from scratch, just to have less time difference between them. Cool, so that was the right one. Disable right, enable left. the other way around, but it's still fine. And this is going to be the left one. Okay, so left, right. Let's go to overlays. And we can see both of them starting at the same time. So that's perfect. Now, when we have this, this is time. What we can do, we can check phase as well. To check phase, we need to go to all SPL. I'm just going to zoom in here just to see both of them. Again, frequency response absolutely doesn't matter. We're going to go to actions and alignment tool. So alignment tool lets you to kind of virtually align the drivers. I'm going to choose the top one, left one, which I'm not going to move because I will be adjusting the right one, the closer one to me. And we can see here, we have the same options for the smoothing, and we can align either phase, either impulse. So if I choose the impulse, and here at the bottom, you have delay, and you have fine delay. I'm going to zero this out. If I'm going to take the slider and move it, you see at the bottom, here, you have the impulse response that moves. So you can kind of simulate how much delay do you need. You can go through here, and at the same time at the top you see green and blue is individual drivers, and the black one is the sum. So you see, if I'm going to shift the mid-ranges something like this, which they're out of time, and you can see here we have a cancellation, so they don't sum, they have comb filtering. So I'm going to leave it at 0 because at 0 they do match in time. Now let's check the phase. If we're going to go to phase alignment, yeah, we can see that the phase, which is here in this region, matches not perfectly, but good. Can we match it a bit better? Let's have a look. If I'm going to shift, there we go. So yeah, if I'm going to shift the phase, you can see that I can align them a little bit better here in the crossover region. But this part in the higher frequency kind of suffers. If I'm going to leave it at 0 like this, yeah, this part is not very nice. So what we can do is we can select a cursor like anywhere and do level phase at cursor. What it does, ooh, it made a mess. Let's try somewhere else just to make the phase graph a little bit nicer to look at, because it's very difficult. There we go. So the phase is more important in the lower frequencies than in the higher frequencies. In the higher frequencies, we're going to have some stuff happening due to reflections. So what we want to do is we want to match like this, because they're crossed about 200 hertz. You can see they're going down. We need to match the phase best here. Now, I'm wondering if we can do a better job than we did already. This kind of maybe would be a little bit better, but then if we're going to go to time impulse, we can add another 0.2 milliseconds to the right driver, and it's going to be a little bit better phase alignment. So let's do that. 0.2 on the right mid. So that's going to be 115, something like that. Cool. And now, again, I'm going to remeasure both drivers, because the key part is to take the measurements very close to each other to not allow for any clock drift. Okay, so that was the left one. Now let's measure the right one. Measure. Okay, again, right and left. Now let's have a look at the phase now. Actions, alignment tool, and right. There we go. So I'm gonna again level the phase. There we go. And we can see that here in the crossover region, the phase is very, very good. Now here you can see at the top, they're not in phase, but this, I guarantee, is going to be just because of the microphone position, because it is a stationary microphone. So you will have some cancellations, some reflections and stuff happening at the higher frequencies. That's why the phase at higher frequencies is not that important. But we can see that the impulse response is good. We cannot zoom in into impulse response here. We need to go to the overlays. And you see, for some reason, now it shows a big difference. And now we can see that this impulse response shows that the drivers are not in time. So they are in phase better, but in time worse by 0.2 milliseconds. That's exactly what we added. Just because most likely the slopes are not perfect. Because again, this tune that I did is not perfect, it's not ideal, and we're gonna have some discrepancies. But again, this is just for you to show how it's done, not to have a perfect alignment. But we can say that they're phase aligned, they're time aligned. They're not time aligned perfect, but it's fine. I'm not worried about this. So what we need to do now is we need to measure and time align tweeters with the mid-ranges. So let's take both of the tweeters and let's do a sweep. But again, now we're going to do left plus right. So we're going to be both tweeters. And straight after that, I'm going to enable the mid-ranges. And I'm going to leave the tweeter for the chirp. And in the sweep, I'm going to change this back to right. Now, if this feels confusing and there's a lot of steps, it is both confusing and it is a lot of steps. So it might be more beneficial for you to buy like an audio interface rather than doing this because, yeah. So this is tweets and this is mids. Now let's have a look at an overlays, and we can see here, if I zoom in a little bit, there we go. This is the difference between mid-ranges and tweeters. Again, I'm going to put my cursor here, and I'm going to zero out on that cursor, set 0. There we go, just to have a better reference. And I can see that if this is 0, my tweeters need adding some delay, which is about 0.257 milliseconds. So I'm going to go to this time window and I'm going to put both of these tweeters on group 1 so that I could adjust both of them at the same time. So now if I'm going to grab one, you can see the other one changes as well at the same time. And it was 0.025, I believe. Yeah, 0.25. Cool. So, and this one added again 0.25 to that one. Now, again, let's remeasure exactly the same just to see if we are closer. I'm going to close this. There's a lot of measuring and a lot of remeasuring. Let's do it again. Okay, so these are the mid-ranges. Now, very quickly, disable the mid-ranges, enable the tweeter. For the tweeter, change this to left plus right, measure. And let's go to overlays, and bam, we have both of them starting at time. It's not 0, but it doesn't matter because it's, again, it's reference. So they both start at the same time. Tweeters and mid-ranges need to be aligned by time. Now, mid-ranges and mid-basses, time and phase, and mid-basses is phase. So now we know that 4 of the drivers that we have, they're time aligned to each other, and pairs as well. So mid-ranges and the tweeters. Now, what we're gonna measure the mid-basses. So I'm gonna take the left mid-bass first. I'm gonna close this, measure. Don't forget to change this back to right. Left mid-bass. Okay, quickly switch back to right mid-bass. Measure again. Cool. That's left. That's right. Let's have a look in the overlays. Let's do this. Actually, for mid basses, because they have a big response, we can measure. We can check here with the alignment tool, left and right, because we will be moving the right one because it's closer. And here you can see they're not in time. So I'm gonna move this a little bit, something like this, and now they are in time. Now I'm going to switch to phase alignment and see that they are in phase. The only thing I want to do, I'm going to level the phase just to see it a bit better. Maybe a bit here. There we go. And just double, so we have 1.44. Let's just quickly play around a bit if we can have a bit better summation. Yeah, something like that. It doesn't matter that much. The main thing, we can see that here the black line gives us plus 6 dB of summation in the whole region. So 1.65. If we have less, you can see there's some stuff happening here. So you can kind of aim for best summation, and at the same time look at the phase as well. So 165, perfect. So for the right mid bass, 165, add mid bass right, add 165, perfect. Let's double check it. So to double check again, we need to remeasure them one after another. That's one. Cool, that's the right one. And straight away the left one. Okay, so again, left and right. Let's go to alignment tool, check the phase alignment. That should be left. Level cursor. And see, for some reason, it doesn't align that nice. Oh, because this is added. Okay. Yeah. So it keeps, for some reason, the delay between, even if you delete the measurement, it just keeps in the tool. So apparently this delay is not tied to the actual measurement, but to the actual tool. So you just need to remember to remove the delay. But yeah, we can see here the phase matches. And if we choose time impulse, there we go, the impulse aligns as well. We can double check here in the overlays just to have a better view. But yeah, perfect. Maybe not perfect, but good enough. So now we need to align the mid-bass drivers to the mid-range drivers. So I'm going to be playing both mid-bass drivers at the same time. Let's take a measurement. Cool. And after that, both mid-range drivers. There we go. There we go. If we go to overlays to see the time, we can see that they're kinda maybe like half a millisecond. You see there's a difference, but again, this is time. Let's check the phase. At all SPL, actually let's name it. So mids, and this is bass, mid bass. Actions, alignment tool. So you can see the whole thing is that you're you're aligning left to right individual drivers, and then you're aligning driver pairs to each other as well. So see, for this it's difficult to see the impulse. So let's choose phase instead, and let's try to see better phase in this region. So can I level the phase? Yeah, kinda. So the mids is gonna be the blue one. Can I align it a bit better? Something like this. So this at the bottom end, you see the phase kinda doesn't match, which is very, very low. If you look at the frequency, it's like 73 hertz. It doesn't really matter. The main thing for us is to match in the crossover region, like around here, to have a good summation. So one octave below, one above. So if we crossed at 200, we need to kind of try to match it from 100 up to 400, which is this region. So the main thing we're going to be looking at is summation in this area. Can we have the summation better or not? Let's have a look. So it's going down, it's going up, it's going down again. Yeah, I think something like this. I think something like this is the best that we're going to get. So for this, we need to add 0.75 milliseconds to the mid-range drivers. Now remember, when we align the mids to the tweets, we had them together. So now what we need to do is, in the DSP software time, we need to group both tweeters and both mid-ranges, because mid-ranges and tweeters are already aligned to each other. So we don't want to change that relationship, and we want to add that, how much is it? 0.75. We need to add that 0.75 to all the drivers. So let's do that. 0.75. And it added that 0.75 to this, and to this, to all of them. Now, again, let's remeasure and see if we have it any good. So delete. Let's measure. So these are the mid-ranges outputs. I'm gonna disable the mid-ranges, enable the mid-bass. Measure again. Cool. So let's name it very quickly. Bass and mids. Let's have a look. Let's double check. Overlays. See, they start at 0. That's perfect. Let's go to action alignment. Check the phase. Mids. This one we need to change to bass. And level phase at cursor. There we go. So I think this is the best that we can do. If you want to do better, you need to play with the crossover points, with the crossover slopes, maybe some all pass or something. But this is the best that I can do with the situation that I have now, which is perfect. They are in time and kind of almost in phase. So just to check the summation, what we can do as well, enable tweeters and mid ranges and mid bass, so all 4 drivers, and just do one sweep. And the sweep shows us, see that this is our mid bass, this is mid range, and they sum like plus 6 dB, how they're supposed to sum. So we have a perfect summation, which is amazing. And now the last thing is to align the subwoofer to the mid bass drivers. Again, we still need to keep that tweet for chirping, so we're going to keep the tweeter, and I'm going to enable the subwoofer, which is the front subwoofer that I have. Let's measure the subwoofer. And straight after that, I'm going to measure both of my mid bass drivers, which is E and F, because we're aligning both mid basses to the subwoofer. Cool, so I have both responses. If we go to overlay, we're not going to see much because, you see, actually we can. So this is 0, and this one shows, so this is my, see, now I got lost, which is which. The orange is sub, and this is bass. So the orange one, which is the subwoofer, needs adding delay because it's very close. It's in the central console, and it needs about 2 milliseconds according to the time. However, for these lower frequencies, time is not that important. What's important is the phase. So we're going to go to alignment tool. Cool. And we're going to choose here the bass and here the sub, because we will need to adjust the subwoofer. And you can see the impulse, we can try to adjust it and see what happens. So if I'm going to push this like this, yes, we do have indeed a better summation. Even if you can see this, the impulse looks like it's out of phase. I can invert one just for you to see how it looks like this. So they look like they're in phase, but in reality, acoustically, they're out of phase because the sum is negative. So I'm going to keep it as it is. And we can see that this gives us best results. Let's have a look at the phase. And again, let's match the phase in the crossover region, which is here. Level the phase at cursor. There we go. And yeah, we can see that the best result is something like this. So we have perfect phase between what, 50 hertz all the way up to 85 hertz in the crossover region. What's happening here doesn't matter because the subwoofer drops off a cliff and it doesn't contribute to the sum at all. But we can see with this delay, what we're going to have a nice summation of probably like 6 dB, and they're going to be in time as well. So we need to add 1.65 to the subwoofer. And let's do that. Subwoofer 1. Let's add 165. And again, let's just remeasure just for sanity and see if everything aligns perfectly. So let's measure the mid bass. Okay, done. Let's enable the subwoofer. Let's measure the subwoofer. And at this point, because I am confident enough, we're going to measure the rest. So again, let's go to the mid-ranges. Let's measure the mid-range. And the tweeters. So I'm going to enable this tweeter. And remember, for the tweeters, in the measure tab, we need to change this to left plus right. Just for the tweeters. Cool. So we have all of our drivers. Again, don't look at the frequency response. It absolutely doesn't matter. What we need to look at is the time. And we can see here, if I'm going to maximize it to better see. There we go. So let's do it one by one just to see it a bit better. So this is the mid bass. You can see starts at 0. Perfect. Then subwoofer starts close to 0, but again, the phase matching is perfect. Then mid-ranges start at 0, and tweeters start at 0. And this is exactly what we want, to have all the drivers starting at the same time and be in phase. So just for fun, because why not, let's measure all the system together just to see if we have a good summing throughout the board. I enabled tweeters, mid-ranges, mid-bass, and one of the subwoofers. Let's take a very quick sweep. There we go. And we can see that we have very nice summing here. Everything is above, plus 6 dB in this crossover region, in this crossover region. Here we have a little bit less summation, but again, this is just because it's not a spatial averaging, and it's just a single microphone position and not optimal location as well. So the main idea is to have very good summation here. And this is pretty much how you do it. So just to summarize, what you need to do is, in the input output, you need to make sure that only left tweeter, or in your case, if you're going to be on the left hand driving car, is going to be the right tweeter, basically a mirror image. You need for one side to play only the tweeter, and for the other side to play the rest of the system. And then in REW, you have the main signal coming through one side and the chirp coming from the other side. And then measure one after each other straight away to minimize the clock drift, because clock drift is still happening, especially when you're swapping drivers. Measure one after each other. Align in time both tweeters to each other, both mid-ranges to each other, then mid-ranges and tweeters together according to time, not phase. Then align both mid-basses, then mid-bass to mid-range in phase and in time, and then double check the subwoofer to phase align with the mid-basses. So I know that this video was probably extremely confusing, and again, I'm going to repeat myself. go to RTA in Cars and download the document made by Pizza, because this video is all credit to him because he did the document and I just followed. He had some extra steps and stuff, but I think for the purposes of the time alignment, this is perfectly good enough. EQ is totally other thing. And I hope that this is going to help a lot of people that don't have or don't want to invest in a XLR microphone and an audio interface, because a lot of people just buy a USB microphone and it's perfectly fine. It's not ideal. It's much harder, much difficult. So I did this in what, an hour probably now. If you would be using something like JL Max or Smart, it would take you literally 2 minutes to do exactly the same thing that I did in 1 hour. But again, if you have just a USB microphone and you don't mind spending the time, follow the guide and do all of this. So I hope it was useful for some people. Thank you very much for watching, guys, and I will see you in the next one.